Hey guys, welcome to my the first video of chapter 5, which is actually dealing with Newton's second law, which it's actually, I think it's probably the easiest to grasp conceptually, and it's kind of based around force and acceleration. Now we've talked about both of these principles separately, but I think in Newton's second law we're gonna combine them and see how they interact with each other because we haven't mentioned that very much. I'm sorry about my phone. That happens in many videos, and I should really turn it off. But okay, so now we're going to talk about uh, how do these two principles interact with each other. Now, if you can imagine, if I add a force, so let's say I have this soccer ball. We've been, poking around at this concept here and there in the past few videos. But let's say I have this soccer ball here, and it's just sitting on the ground, right? It has no acceleration because it's really not moving. It has no velocity, okay? But then if I come up and I give it a big kick, okay? If I give it a big kick, it's an awful drawing. It's gonna shoot. It's gonna go this way, right? It's gonna go far. It's going to accelerate, okay? So that's basically when a force is added to an object, or when a force is imposed on an object, it's going to cause acceleration, right? That's 5.1. Forces cause acceleration, and they give the example of a hockey puck on ice, and then they say this, which is kind of interesting. They say acceleration is directly proportional to, this little sign means directly proportional to net force. Net force. Now, directly proportional to means that, oh, I'm sorry, I didn't finish the word acceleration. When acceleration goes up, so does net force, or vice versa. When net force goes up, so does acceleration. That's what directly proportional to means. And then we go on to say 5.2, mass resists acceleration. And another way to say that is acceleration is inversely proportional to mass. And the reason, and how we write that is acceleration, I'm going to use A, is inversely 1 over mass, okay? Inversely means 1 over, okay? Because that means when mass goes up, acceleration goes down, okay? And that's, so up, down, that's in inverse proportion, okay? And then, now we say, well, how can we combine these? I mean, now we want to say, well, I want to know how I can interact between acceleration, mass, and net force all at one time. And we move on to actually Newton's second law, 5.3, which says that so acceleration is equal to or directly proportional. You can use either one. Net force over mass. And this is the key principle that you'll have to know, okay? Acceleration is equal to or directly proportional to net force over mass, okay? So that's very helpful for us to know, right? So now let's plug in a couple numbers just for fun, right? Let's go clear image. I'll give you a couple examples. Maybe we'll do some like word problems and whatnot. Let's see. You know what? First, I'm going to read what the book tells you Newton's second law states, and then I'll kind of interpret it in my own way. Newton's second law states that the acceleration produced by a net force on an object is directly proportional to the magnitude of the net force, is in the same direction as the net force, and is inversely proportional to the mass of the object. So basically what that means to me is that when I'm kicking that soccer ball, and the net force on that soccer ball from my foot is 50 newtons, the ball is going to accelerate in the same direction I kicked it, right? Because acceleration is directly proportional to force, to net force. But it's inversely proportional to the mass. So the more massive that soccer ball gets, the slower it's going to accelerate because it's more massive, and with 50 newtons of force from my foot, it's going to go slower and slower and slower as it gets more massive and more massive and more massive. That's just how these equations interact with each other. So now let's plug in a few numbers. Okay, so let's say if I kick a ball with 50 newtons of force and it accelerates at 10 meters per second squared, what is the mass of the ball? Valid question, right? Okay, so let's figure it out. So let's write down our equation here. A equals F over M, okay? Um, and F force, M mass. And then another way to rewrite this, I know Mr. Trudell likes to say this, is F equals M times A, F mol. He likes to say, like, what'd you get on test? I got an F mol, and I think that's really clever because that helped me remember it always. Um, I really like F equals MA. That's probably how you'll see it the most because oftentimes force is the operative thing that you want to solve for. But in this equation, we're trying to solve for mass, and that's just as easy. So if I kick a ball with 50 newtons of force, okay, 50 newtons, and these are arbitrary numbers. I don't know if I can kick a ball with 50 newtons of force, and I don't know if it will accelerate at 10 meters per second squared when I do that. But let's just do it for fun, okay? So acceleration is 50, okay? And then we know the force also is 10, right? But we don't know the mass, so we're going to put mass here, okay? And now, really, you can approach this however you want, but how I do it, and I always like to get rid of denominators when I'm solving math algebra problems. So I'm just going to multiply both sides by m because that eliminates the denominator of the fraction over here. So you can go m cancels out, and you get 50m equals 10, right? And now you can divide by 50 by both sides to get m by itself. 50, 50, and you should get m equals 1/5, right? So that's basically how that's how you do it, right? So okay, sorry for that little pause there. I had to deal with something. My dog was in the house. So yeah, so mass is equal to 1/5, and now we know that 1/5, and it'll be in kilograms because that's the SI unit. We're using SI units here, so it'll be in kilograms. Now let's just plug it back in to check if our numbers are correct. Okay, 50 is equal to 10 over 1/5, and I know having a fraction is a little strange, but really, if you know the rule that when you're dividing fractions, you just multiply by the reciprocal, this is really easy because then it's just 50 is equal to 10 times 5, and we know that that is true, so our equation checks out. And the mass of the ball is 1/5 of a kilogram, which is fairly light. I mean, fairly not very massive. I should not have used light there because mass is not weight. I'm sorry, my mistake. Mass is not weight. But this has been a brief introduction to Newton's second law of motion. I will see you in part 2.